Welcome to this presentation. These demonstrations are going to illustrate what you should have been learning from your scipad on page 64 to 65. And I need to remind you that we're thinking about solubility of molecular substances. So these are all molecules or molecular substances, and if we go to the whiteboard, you can see the molecules that you will be working, or I will be working with today. Ethanol, methanol, hexane, ethanoic acid, and water. And you need to look at the molecules and what atoms are in each of these molecules. And as you're looking at them, you need to be thinking about whether these molecules are going to be polar or non-polar, and why, and how that relates to their solubility, their electrical conductivity, and even their melting points and boiling points, although that's not a part of the demonstration today. The first demonstration is this one here, where you can test for polar, non-polar substances. And we're going to just take water and put in one of these burettes, and hexane and put in the other, and they both respond differently to electrical or electrostatic charges. So I'm just going to take some water from this water bottle, and I'm going to put it, I'm going to use a funnel just to fill this burette with water. So as you're looking at it, that will be in the left hand side and my right hand side. And titration is something that you'll get used to later in the year, and you'll be using one of these burettes, and you don't want to do what I just did then. But right. And in the other burette, I'm going to put hexane. Hexane is an organic molecule made of only carbon and hydrogen, and I want you to start thinking about what might cause the different responses that these two are going to have to electrostatic charges. Make sure the tap's closed first. Right. So what I'm going to do now is take this plastic rod, and I'm going to rub it in my lab coat, and I'm going to allow the water to stream out, and I'm going to bring the rod close to this. Now you saw this the other day, and it worked nicely. So we'll see if this works. So here's the stream of water. If I bring, and you can see how the water stream bends towards the rod, and I want you to think about why that is. And it doesn't matter which way I take it, it still streams towards the rod. So there's something about water that's causing it to get attracted to an electrostatic charge. I can also take the glass rod and do the same thing. We don't know what charge is on these rods at the moment. That could be positive or negative. We don't know if electrons are being put onto the rod or taken off the rod. We could do some fancy electrostatic. So it doesn't really matter what charge is on these rods, the water still gets attracted to it. as opposed to the hexane. So if I do the same with hexane, that we'll get something different here. And if I bring the charge rod up close to that, even if I rub it harder, it doesn't bend towards the rod at all. So there's a different response here between the water and the hexane with respect to electrostatic charge. And you need to think about what that might be caused by. And we sort of briefly discussed that last Friday. Now, as far as solubility is concerned, we talk about miscible and immiscible. Miscible just means that they mix and dissolve in each other. Immiscible means that they will not mix and they form layers. And we can see this clearly if I put a small amount of each of these liquids in these test tubes. So if I take ethanol first, and I'm going to just pour a small amount of ethanol into each of these liquids. I'm not going to put water because water and water doesn't make any sense to do. So ethanol, methanol, both alcohols, the two simplest alcohols you can get. Then ethanoic acid. Oh, actually, there will be 5 substances, yeah. Ethanoic acid. This is just what's in vinegar. So you could do this at home. Also, just get some vinegar out. Get some rubbing alcohol. Your dad's probably got turpentine somewhere. This experiment is also really important to understand if you have any, if you're interested in painting, if you're interested in being an auto mechanic, if you're interested in cosmetics, all those sorts of things. The understanding of why something dissolves in something else is really crucial to those. And when you're painting a fence or a house, understanding whether you've got oil-based paints and what solvent to wash your brush out in, as opposed to acrylic paints, and what brush to use there. So now what I'm going to do is just take my water, and I'm going to just place a little bit of water in each of these tubes, and you need to note whether a layer forms or whether they dissolve. So there's ethanol and water, and you can see, I can shake that around, and you can see that though there's no separate layers, there's not one liquid sitting on top of the other, and it's formed a homogeneous mixture, which is what we call a solution. So this is actually dissolved, formed a solution, and the ethanol and water are evenly distributed throughout in that. If I do the same for methanol, you'll see again no layers. Again, even distribution of solvent and solute molecules throughout, and they're evenly dispersed in each other. This is true homogeneous mixture, which is the classification of a solution. Ethanoic acid and water, again, no layers formed, even distributions throughout. As you know from home, mixing vinegar and water, you get a true homogeneous mixture or solution. Now, if you try that with oil and vinegar, of course, which is what you do when you're making mayonnaise, you would get 2 separate layers that they eventually come out of solution. Now, hexane and water. This time, you can see that the water goes straight to the bottom. So we've got a layer of water here, a layer of hexane here. Hexane's less dense than water. And if I shake it, mix it up, it goes that cloudy color. But as you can see, once you let it settle, the layers come back. Hexane is not soluble in water. This is immiscible, and this is not a solution. We've got two separate layers going on there. And then the final one is turpentine. Turpentine is a hydrocarbon extracted during the oil making process. And you can see again that the water just goes straight down to the bottom. We've got the turpentine on top, the water on the bottom. That means the density of the water is greater than the density of the turpentine. Shake it up, you get those cloudiness, but eventually after time that separates. So now what I'm going to do is the same demonstration, but I'm going to go put hexane into each one of them. So just give me a minute to put, so I'm going to take methanol, ethanol in that one. I'll do them in the same order. So ethanol, methanol, ethanoic acid, turpentine, and we've seen the water already with the hexane, so I won't redo that one. I'm going to add hexane to each one, just a little bit to each one. So I'll use this hexane here. And this time you'll see that it goes cloudy. Now, the hexane is dissolving in the ethanol. And you have to think about what might be causing that. It wouldn't dissolve in water, but it is dissolving in the ethanol. And that's really interesting, in fact. So there's no separate layers there. Same with methanol and hexane. This time you're getting cloudy, it's separating out into layers. I'm just going to wipe the bottom of this. Eventually you're going to get two layers formed. The ethanoic acid and hexane. Again, it separates out into two layers. So what's causing that? This is immiscible. And then the final one is turpentine and hexane. And this time they should dissolve. So the turpentine dissolves in the hexane and you get one mixture, a homogeneous mixture. And you should think about why that result happened. The anomaly here is the ethanol. Now, why did we not get two layers here in the ethanol? And try and explain that in terms of the bonding and properties of these substances. I'm just going to exit for a minute. I'm going to put these chemicals in the fume hood. Then I'm going to come back and just finish by doing the electrical conductivity. Maybe I'm not going to be successful in that.
Stop it there?
No, just keep it going.
Okay.
Yeah. Mm. Yeah. Okay. Right, we do. Right, so I'm just going to take these chemicals over here. I've got some little beakers. I'm going to put a small sample of each one in the beaker. I've got the power pack set up, and as you can see, when I touch the two ends together, the light bulb glows, indicating an electric current. So the question you should be asking yourself even now, before I do each one of these tests, is would any molecule or any molecular substance conduct electricity? And why? If so, why? If not, why? So what? Remembering, for an electric current you need free electrons or ions. So think about that as I do these demonstrations. So I'm just going to put a little bit of ethanol. I'm not going to put too much. I'm going to bring it over. I'm going to just put the leads, the ends of the leads in, and you can see that the light bulb does not glow. That doesn't surprise me. I'm not sure if it surprises you or not. I'm going to then do the same with methanol. So I'm going to take methanol and put the electrical leads in, see if that sets the light bulb off, but it doesn't. Ethanoic acid, so the vinegar, acetic acid, it used to be called. Again, if I put the electrodes in to the ethanoic acid, we don't get any electrical conductivity at all. The light bulb doesn't glow. So none of these substances so far have conducted electricity. The hexane, I've had that one already. Do the turpentine. So turpentine, again, no light bulb going, no electrical conductivity. If I'm not careful though, the plastic might dissolve. I'm not going to do the cyclohexane or the hexane because I just don't want the fumes going around the classroom at the moment. But it won't conduct. But I am going to do the water. Now here's an interesting one. Water poses us lots of problems when we think about whether it's an electrical conductor or not. But contrary to popular opinion, this will not do what most people normally think it to do. So here's pure water. This is deionized water. Think about that, the fact that it is deionized water. What that means. And what might be the difference between the water that you drink at home and this. When I put the leads, I just double check that the light bulb's still going. It is. I put these two leads right in the water. Make sure they're in the water. And you can see that the light bulb does not glow. Now just to make sure, to prove to you that there are no tricks going on here, I'm going to get a metal spatula or some form of metal somewhere. Just give me a minute, I'll go and get a spatula and come back. Here's a metal spatula. I put that on the thing and you can see that the light bulb glows straight away. So, none of these molecular substances conducted electricity. The metal spatula did. If I put some salt into the water, I would get an electrical conductivity. So So there's a lot to think about there in that video, but it answers all the questions in the scipad that you need, and it gives you things to think about. How is the bonding in molecular substances related to these physical properties? The end.